Login accepted.
Hello everyone, it's a pleasure having you here. So I would like to introduce my speech about top 10 big data system pitfalls. I hope you'll enjoy it. So let me introduce myself. So my name is Piotr. I'm a founder of the company Devoxx, and today I will share mainly war stories. So some technical and business stories about what went wrong or what could have been done better in the projects I've been leading. I'm leading multiple big data projects for more than 7 years right now. So this is the knowledge that I would like to share with you. Personally and technically, I am a big fan of domain-driven design approach and Druid.io as a technology. However, I would like to say a few words here that this talk is midi-core technical. I would rather treat it as some bridge between business talk and technical talk. So I'm here for you, not the other way around. So if you feel that this talk wouldn't fit you, you can leave. I won't be mad or something like this because it's your time, your presentation. And one more thing, I have some gifts here, like some sweets or some glasses. So if you ask proper questions, the right one, and I will do my best answering, I will share it with you. So after the talk, you're also invited to be here. So about the company that I founded, it's more than 20 big data experts right now. We do only big data projects. So this is also important because this is the knowledge that I will share with you. And we cooperate with global brands which have dozens of data. Typically, we're working with terabytes, sometimes with petabytes of data. So this is quite a good volume, and we're 4 years old. So let's start our talk. So it might sound interesting for you that, first question, do you know some kind of a technology that has a typical landscape looking like this? That there's so much technologies and they are coming in and in every week that you don't know which one to choose. Does anybody know such a, I would say, area in software development when this occurs? JavaScript, that's right. Somebody already won a sweet. So previously, in big data world, this was kind of similar, that there have been a lot of technologies, and it's a gift to know which one to choose. Because as you would find out during this presentation, there's only a limited set of technologies which are worth exploring and worth testing, whereas the landscape is quite impressive. However, most of them are already deprecated, or you shouldn't use them due to some purpose. So I'll go with that. And the first question that I would like to raise, and I would raise a few questions for you so that you can think during this presentation, is about why big data development is so difficult. So as we already said, the ecosystem is as stable as JavaScript ecosystem. So this is kind of tough because you don't know which technologies you should pick. But do you know maybe some big data technology which is quite old these days and it's very difficult to upgrade and maintain? Anybody? Hadoop, another suite for you. So this is very difficult area, and as you've seen in previous talks, in order to do good software development, you should probably use up-to-date versions. So with Hadoop, this is very difficult. And this is, I would say, the grandfather of all big data technologies. So next thing is that the scale of the data is really going impressive. You can see here that we had a pandemic times, and we have some forecasts about how the big data business would grow. So you could see that during the pandemic times, the growth of the data incoming is really massive. For example, when it goes to messaging systems, it's 40% more data in 1 year, whereas the forecast was, for example, for Facebook, that the amount of the data consumed will actually drop, whereas it did grow. So multiple companies after pandemic have even much more data sets and much more valuable data sets than before. So actually, this kind of business, big data, really grew like mad. And one important thing, I think it was already raised here in different talks, but if you think about some distributed systems, and in big data you will find only distributed systems because others simply won't scale, it's very difficult to test such systems from end-to-end perspective because it's easy to test in isolation, but it's very difficult to go through some end-to-end processing. And actually, it's quite a young area of software development, big data, because as we mentioned Hadoop, it's 2006, so it's 15 years old. So it's not even mature, it's not 18 years old. So it's quite young, but the true big data development that became popular and people could have started developing their pipelines started with Apache Spark. It was introduced in 2010, however, only when the data frames were introduced in 2015, this is when the boom started. And actually, I'm the lucky guy who worked with Spark before data frames, so I know the history, but I discourage you working without data sets because it's a nightmare. However, in 2021, big data technologies are becoming mature. It's quite good these days because if you are to take one technical thing from this talk, this would be which technologies to pick for your initial big data project. However, the industry is hard because there's a limited number of big data developers. And what's even worse, typical big data developer is a full stack developer. You have to be a good software engineer because you will work with distributed systems. You'll have to create a lot of code base. And what's even more difficult, you'll have to understand some hardware underlying and some architecture because you will have to tune it and optimize it. And this is very difficult because probably I've been in a great talk by Mr. Nabrodalik today who said that, okay, microservices can run on any crop. One CPU, 2 gigabytes of RAM. This is not the truth in big data area. So probably it would be nice if you understand how core computing work and how the parallelism works, like what's the context switching. So it's a lot to learn. And there's a business aspect too, because, and I would say that this is a very important statement, ask yourselves who are the business stakeholders in your project. Typically, in web applications, stakeholders exactly know what they expect. Whereas, because in the end you receive a web application which performs some business actions, right? It's quite easy to imagine. But please try imagining big data system which does not have a front end. In the end, it's all about data processing or about cloud computing. So it's very difficult to imagine what's the final outcome of the solution. And what's even worse is the fact that as you will see this, and I will tell about it, you will have to educate most of the stakeholders because, please believe me, this will be very hard for them to imagine what are the next steps, how we should test that our big data project is going with some milestones, how to define those milestones, what are the outcomes, what are the problems. This is really difficult. I know that it's difficult in web applications. However, in big data systems, it's even harder. And the most challenging part is that you will work in a distributed environment. So even though microservices opened this world to the software engineers, that now we somehow know how the distributed environment works, here it's massive because it's going with the scale. And as the scale grows, you will probably have to go back to your university teachings and you will have to learn how algorithms work. Because here, when you think of the algorithm choose to process millions of records comparing to billions of records, this will actually make a huge impact and huge outcome on your project. So small things matters, and this is really difficult part because the learning curve is so great. But by the way, who among you have finished computer science studies? Okay, quite a bit. What's the academic definition of the computer program? No candies this time. So I checked it twice. The most easy definition is that computer program is a piece of software which processes the data. So big data is all about processing the data, so it's quite close to the roots of the original vision of what's the computer program. And something that the companies does not imagine in the beginning, but once they start the big data projects, they do realize it, is that you will be working on the second most important asset of the company. Because most of the big companies, pharmaceutical companies, e-commerce companies, they won't exist without two most important things. Do you know what's the first thing? People, employees. Company without employees does not exist. And second is the data or customers. This can differ. However, those are two main important assets for the company. So, as it's about top 10 mistakes, I put them chronologically. So step number 1, not knowing your data. And I would go with examples. So let's consider e-commerce world. In Poland, we have a great company called Allegro, which I had the pleasure to work with. And it's an open question. Do you know what's the most important data that Allegro keeps? For them. How would you think? And it's typical for each e-commerce. Customer base, number 1. And something that's equally important? Transactions. So now let's think how big those data sets are, comparing to other data sets they possess. I will give you a hint. Let's compare this with clickstream or mobile application clicks. How do you think? How many clicks a single user does in his whole history of life in Allegro? 20,000. I think this depends, and this will change over the time. However, it's way bigger than the customer base and transactions, right? So a good company knows which data sets are the most valuable one. And what's funny thing, if you start with the most important data sets, you'll find out that they are not so big as you expect, because the surrounding ecosystem is so big when it goes to big data, whereas the core data sets, probably they might fill into the memory. So this is shocking for some of you. However, this is something that the people starting working big data projects does not realize, and this is very bad if they don't. Because you should start your project with the most important data sets, because it might cause less issues, less problems, and less software development activities when it goes to scale. Next thing is that ideally, you should know what are your query access patterns. So what are the types of the queries that you would like to ask? As I heard during this Devoxx presentation, there's no good architecture at all. There's only architecture optimized for different use cases, and this is totally the truth. If you design the big data system that's for everybody, actually it's for nobody. So you will have to find out what are the access patterns so that you can start optimizing on them. And this is also crucial. So why do I do this big data project? What will be the type of the queries that I will try to find an answer to? And I would say another big piece. So do I really need to keep the history of all my data sets? 1 hour ago, there was a great technical talk about Druid.io. And this technology lets you run massive queries in no time. But thanks to the feature that it does not keep all the raw records under the hood. However, ask yourself business questions here. Developers don't do it very often, but big data engineer does, or good big data engineer should do it. So the question is, do I really care about each user ID processed 10 years ago? Or do I care about the number of unique users who bought items before Christmas so that I can check if my logistic sub-company would keep up to date, so the delivery is on time? Ask yourself these questions, because if you find answers, you'll see that your big data is not so big, or it shouldn't be. And last but not least, when it goes to the data, there's something called data quality. And it's an open question to you. How many of you measure the data quality? How many of you have 2 levels of validation of your input? 1 level of validation. More than 2? Okay, so have at least 1 level, but it's like trust, but measure. You can trust the data quality, but you should always measure it and check it. And there are ways to do it, and I will tell about it very soon. So once we know that there are some data issues, then we should go for the business domain. So, for example, I will tell you about the project that we did for some Asia Telecom. That was really heavy for us. We learned a lot. Now I can tell you that I'm an expert. But what hurt us a lot was a bad business domain, and we didn't realize it. So, question is, what is a bad business domain? Bad business domain is something that changes very often and is not compliant, so not backward compatible. And I will give you an example. We did some kind of a Netflix for Thailand telecom operator. By the way, how many Thai people live in Thailand? Do you know? 80 million, exactly. Twice the number the Poles live. So, you know, when we started, we thought, it's a big telecom company. How many users can they have, right? And actually, they had a lot. So the volume of the data was massive. But the most challenging part was that they did parallel tracks of development. They've been developing backend system to gather clickstream data from the television sets and from the devices. And we started the big data project analyzing this data. And this was a nightmare. Do you know why? What's the most popular format of the data sent through HTTP requests? JSON. Does JSON have a schema? No. Can you change the schema? What happens if you delete some columns? Some fields, sorry. Nothing. You'll break all the analytics down the road. So imagine, we had an integration part where they changed the schema in the beginning 20 times per day with no backward compatibility. Imagine this. Just please do imagine this, how it worked or how it did not work. But there are tools to go over it. However, you have to know it, that it's a very bad business domain. Because after 2 weeks, we changed the business domain and we started working on some things that are movies, episodes, programming channels. This is something that doesn't change, right? You don't develop it from scratch. And for example, such a good domain does not change that often or changes the way that it is backward compatible. And something very important for the management people. Managers are thinking in terms of reports, right? They love reports. However, it's not the way you should design big data systems. You shouldn't think about the outcome of a report. You should think in terms of a data flow. How your data is going to be processed, how many ETL pipelines you have to implement, what's the final schema of the data, what's the original schema of the data. Because reports are the snapshots of existing system, right? And one more thing that I have to call out here is that there's no one-to-one system replacement. Do you know what's the most popular big data project? These days, obviously. Any guess? Replace old system. To where? To which kind of infrastructure? Yeah, it's cloud migration. Everybody loves cloud, right? However, do you know what's the nightmare requirement from the business? Deliver the same system. Please give me what I have already, right? So, well, if it's the case, you shouldn't touch the system at all. Because if you are to replace the system, things will change. And it's inevitable. You have to be aware of it from day one. So it's a worst case of scenario. Give me one-to-one system. Another thing, forget about CRUD. There's no databases at all in this domain. So there's no CRUD. And especially there's no update. Delete, okay, we can live with it, we can support it, but there's no update. Good big data projects should work on immutable data sets. Because if you update something, well, all the performance can be, dropped. It won't work that fast anymore. So update statement does not exist. Stop thinking about CRUD. This is another important issue. And something that's also said during this conference, data is always eventually consistent. So what's the report? The report is a snapshot of the data inside some analytics system, but it's a snapshot. It's not something that you should rely on. And if you had an opportunity to listen to my colleague Michał, the typical problem is counting distinct users, right? How many people watch my movie? How many people saw my commercial? And here the answer is that if you had all good MySQL system, probably you were able to count it during 2 hours of time. This query ran for 2 hours and you got the exact count. Whereas in big data systems, it works differently. I will give you answers in 10 seconds, but I would say, reliability is 99%. Can you live with it? Is it good enough for you? Do you really care about this 1% of difference? So next thing is that you should choose proper technologies, because if you don't, it will be a nightmare building this software. So the question is there any common stack? And hopefully the answer is yes. So there is a few areas in big data projects where you can group technologies. First part is data ingestion. And here there's a very cool technology, Apache NiFi, if you would like to give it to business people, or you can obviously develop some custom API. Then for the processing, probably you will use Apache Spark or Flink. Maybe if you're a hipster, you'll use Kafka streams. But the question is, why probably Kafka streams won't suffice? Do you know? We'll go into that later. And you'll have to use some storage. It might be on-premise storage or some cloud storage. Then if you really need to have a CRUD in your data, or at least, I would say treat it as a CRUD. There's a hoodie. For data warehousing, there's Apache Kylin or Apache Druid. So hopefully there are technologies. All of them are open source. There are good UI visualization tools, especially Tableau or Superset. So there's something to work with. So you don't have to think about it. And these days, we speak more and more about the data virtualization. So there's a really cool startup called Drem.io. They fixed this problem. And this is really working like a charm. So if you think about the architecture, there are different layers. But not only layers. There are different types of data. And in the most basic language, we should split them between offline and real-time data sources, right? Offline data sources are called batch. Real-time are pushing the data somewhere. So the first layer is the data integration. So this layer ends up when you put the data into some persistent storage of any kind. Then we go to the data processing layer. Here, for example, you can use Apache Spark. I'm a big fan of it because it's a one technology that supports both real-time and batch. Don't blame me that I'm saying it supports real-time. It does for most of the business users. Who among you is using Apache Flink? What's the minimum amount of time that you can process the data with Flink? One second? Less? Less than 1 second. That's a good answer. What's the minimum size that you can process data with Spark Streaming? It depends, but typically it's 10 seconds. Why? Because it's not a true streaming, it's micro batching, right? However, the case is like this, that if you ask your business, what's real time for you? The answer may differ. It might differ a lot. For most of the business, if they can see the data in 10 seconds, it's a real time. Obviously, there are systems which needs to work in sub-second latency. However, in analytics, I don't think so. So it really depends. And then you've got the data warehousing part. So this is an input for the future analytics. You should support some kind of an UI here to share with your business users. And you should have some SQL access, like, for example, Presto. So knowing the technologies, there's one thing that you shouldn't do. You shouldn't design upfront. So, and here, another question for you. Do you know when the data stops fitting into Excel? Any guess? 1 million. True, even less. Somebody calculated it, and it seems that with 1 request per second, when you take the whole day data from a day, this is the boundary. So now ask yourself, do you have 1 request per second? And you would guess that probably yes, but for some data sets, probably no. So some of them will even these days fit into Excel. And please believe me, there's no better business tool than Excel. So you wouldn't compete with it. However, if you have more than 1 request per second, this data won't fit. So you know when the big data is really big. So it starts from more than 1 request per second, so it's quite easy to deliver. And one thing, do you know why Hadoop had so bad time these days? Why people don't value Hadoop at all these days? You said it's hard to upgrade, that's true. But the worst thing is that it's such a big ecosystem, so complex, and that it's very hard to move it from one place to another. And these days, as we already mentioned, typical big data project is cloud migration. So if your technologies doesn't work in containers, they are not scalable, and you cannot change the deployment, ideally using some Kubernetes cluster, so then it will be very hard to maintain and to move around. So think about this while choosing the technology. Is it easy to virtualize? Is it easy to scale? Or would I have to live with it for another 10 years without upgrades? And here, something that we already said, you should prepare for a change. So as I mentioned, the data will change. Data should be compatible. This is what a schema evolution is. And as you know, JSON is the best, but for services, not for data analytics. Do you know Avro format? It's a very good row-based data format, binary one. Typically, the data weights 10 times less than JSON. So that's rule number 1. However, the biggest case is that it has a good old schema. And this schema can be stored in schema registry, and it can evolve. And this is what you should start with building your software day 1 in big data. Start with a schema. My customers typically ask me one question, and one, I would say, business requirement when we start discussion. I would expect this system to be scalable, reliable, and that this system would work with all kinds of data. And I'm always answering, okay, like, you know, you can have Ford car with any color you like, but the black. So here it works like this. If you start with schema, it will support all the data. Having a schema which is evolving. Because there's no good system that works on top of unstructured data without any schema. Why? It will break someday. I won't tell you it's day 1, day 2, day 3, but this is something you don't want to work with. Because think about analytics, right? Typical use case, if you do not support a schema, is that your analytics people will type SQL queries, right? They will fetch some kind of a column. And what happens if this column disappears? For specific periods of time, this query would work. For specific periods of time, this query would fail. Is it a good system? I don't think so. So it's a very good use case. Start thinking about the schema. And do not believe in myths. Because if you type for Stack Overflow, what's the best big data format? Do you know the answer? JSON. Second? Parquet. Who amongst you know Apache Parquet format? Okay, the difference is that Apache Parquet is a columnar format, right? It's great. It's super cool. But if somebody tells you Apache Parquet is better than Avro, why? Because I read in Stack Overflow. That's not true. That's cargo cool. Avoid it. Why? Because Parquet is super cool, but when you do select statements, because columnar formats works best when you drop different columns, because you take way less data and you don't process each record. But what happens if you have to process all the records with all the columns? No value added at all. And the burden of the metadata is way bigger than any value. Do you know what's kind of a system processing all data with all columns? That's the ingestion part. That's the ingestion part of our big data system. So if you are processing raw data, start with Avro. Once you go to query data, go with something columnar. But this is one of the lessons learned, very tough. So next thing, we already saw the layers. You should be aware that these layers exist. Those layers are ingestion, processing, warehouse, and visualization. 4 layers. And this is the question why it's good. Do you know, actually, why people started doing front-end development and back-end development in parallel? Why it's good for software development? You can specialize. That's good from the people perspective, cool. But from the business perspective, it's faster. You have to agree upon something, right? That's contract, that's your API. But it's faster. You can start doing this in parallel. And it's the same in big data projects. You should think about the layers that you can split your team and work in parallel. And it's very similar to microservices world, because these layers have to integrate. And it's another reason why Avro schema is so cool. It provides a schema. And this schema is your contract. This schema is your natural integration test out of the box. And as in big data software, you will do a lot of integrations. This is like very valuable to have it. And the dream team. What's the typical dream team? Obviously, big data developers. For sure, you'll need some DevOps people in your team because you'll have to deploy it. And this is tough. But it's very important to have at least a domain expert in your project who will guide you through the data sets. Because probably you are not aware of the things that live in this data. You won't have much time to learn them enough. But there are people who know the structure of the data, the format of the data. Does anybody here work with healthcare data? Do you know FIRE model? Have you ever heard about FIRE modeling? So this is a very structured way of, this is a hospital integration system, okay? If hospital needs to send data to some provider, they have to follow this system. And it's a very strict schema. However, good luck learning it without domain expert. If you have somebody like this on board, he'll guide you and you'll get to know what's inside. But there's something worse. Really a nightmare. Not thinking about the users. You should, from day one, optimize your system for specific use cases and users. So there are different users. There are technical users and non-technical users. And among non-technical users, there are high-level users and lower-level users. So first of all, there's one language, which is a king, and your software have to support it. This is SQL. That's the language that most people speak. Who among you knows SQL? No matter if you're front-end developer, back-end developer, data analyst, you speak SQL. That's our language. So there are people who don't speak SQL. And typically those people are giving the money to the project. However, they know how to click intuitive UI. And this is something that you'll have to support too. If somebody doesn't speak SQL, they have to have a good tool to click through the system and be able to analyze the data. Why? If you open the data to the business people, it might end up 2 ways. Your project either will end quickly, or you'll get more funds and this project will grow. Why? Because when you open the data to the business people, they see the value. They stop thinking in terms of this is my cloud migration. They start thinking, I got 2,000 users more. We got some promotion. maybe we should do it more often. Then it drops, people don't go back. Maybe I should count what's the value for money. If I put an ad for $1 billion and it gives me 2,000 users, is it worth the effort? What's my CTR levels? What are the click-through layers? So these kind of questions starts appearing, and this is the way that this business is transforming. So actually, this should be your goal, to share this, because if you're developing software, you're always selling it to somebody. And what's the best way to sell software? Having a good UI. Sorry to say that, but backend developers do the engine-based work, yeah? It's like with a car. You're expert doing engine, but most people care about, nice layer on top of it. Sad but true. So, there are some tips and tricks to speed with management. First of all, educate them. They won't know much about big data. You have to share this knowledge with them. They have to be on your side. We typically work 8 hours per day. This is more time that I spend with my family, right? Maybe not in pandemic times. However, I spend a lot of time with business people, so I have to at least align with them and speak the same language. So you have to have them on their side, but not at all cost. As they are not aware of the technical details of the implementation, you have to start learning one very important word. And this word is no. It won't work this way. No. We won't keep this functionality. Will it work faster? Yes. Will we count exact result? No. So the system wouldn't work the same? Yes. So what's the purpose of migrating the system that will work differently? You have to be able to answer these questions. You have to educate people with the technology, because really big data technologies are difficult, but there are different use cases, right? So, for example, one important thing. If you want to migrate some old functionality, don't do it based on reports at no cost, because report is a snapshot. Probably you might even have different data structures, so you won't be able to perform the same report, right? And I'll give you a good example. We did a project where in the old system, you were able to see how many commercials were presented and with what level of CTRs during the video episode, right? Whereas in our new system, we didn't have access to such data, so we weren't able to produce this report. Business people didn't understand it because there were different types of queries that we were able to support. We were able to tell you that this specific ad was watched by this segment of users, and these users are of this gender, coming from this region, watching this episode. But there were no global statistics because we had it grouped. So the question is it improvement or going backward? But it's not the same functionality, so you have to live with it. And one thing that I have to always discuss with the managers, partitioning. People who are not technical doesn't know what's a partition, right? Have you ever heard about partitions? What's the killer feature of partitioning? Partition pruning. You can select specific subset of values from a big source. But this requires some technical knowledge and implementation, and this typically takes time. And when we are starting the project and we get access to the data, one of the first things that we do is work how we should partition the data. And then there's a question, what's the partitioning? Why do I need it? I never thought about it. Okay, so then some easy to answer reply, yeah? Think about, you'll have it in 5 different machines, and based on the partition key, this one will land here, this one will land here. I have patients from Ohio, Texas, New York. These are 3 big states. We'll keep them on 3 different machines. It will work 3 times faster. I like the partitioning. How will we implement it? Those are the questions you should be able to reply on. And this is one of the nice intuitive UI. I would like you to watch this demo, because this is something that you can present for your business users. This is Allegro's open source presenting Turnilo. It works with Druid. And this is a tool, BI tool, which will give you some hints how big data systems could look like to be accessible for end users. For example, here it's a visualization of the changes that's occurring in Wikipedia page. So this is something that should be somewhere in your mind, that you will have to present it one day to business people, and they would like to do some drag and drop features. Okay. So then something that we shouldn't do. You know, we're doing data lakes, right? But sometimes data lakes turns into the data swamp, where the data doesn't have a structure, doesn't have a schema, breaks often, works slowly. It has a name, it's a data swamp, and there are ways to support fighting against it. Typically, it's OLAP system. So it's not a transactional system anymore, it's analytics system. The problem years ago was that the OLAP systems were commercial and very expensive. I already presented you a demo of the Druid, which is an open source system, but it works on top of aggregates. And here, it's a very good question. How do you think? Do business people access raw data? No. What are the typical queries that people ask? Aggregates, group by queries. Give me top 100 companies that sold electronics between 25th and 27th of July, right? Queries like this. Those are called aggregates. And probably you may end up having a specialized big data system supporting only aggregates, because this is the place where your business users would go. Or your applications. Think about application level access. For example, if you have a promotion application which should send some SMS and codes to have a discount, it will probably start with querying of the aggregates, right? Give me top N values of people who might be interested in promotion, right? So those are all aggregates. And the older the data gets, you can roll them more often, right? So for example, if it goes to keeping the numbers, after 1 year, maybe it's good enough to keep just a single number. Don't worry about this. Most people will get it. Like, what's the number of your users watching video 1 year ago? Do you think Netflix keeps all this information online? No. If you read blog posts, they are rolling all the data all the time. Because after events appear, they don't care. Analytics don't care, applications don't care. Data scientists and machine learning engineers care. But they are technical people. So it's a bit easier working on top of raw data with them. And something that hurts, really hurts. Okay, my system does not have the same functionality, but it should match the results. The results should be the same. Those are your ready-to-go tests. In the end, you should test that the old system and the new system should have very similar results. In the great use case, the same, or at least very similar. But if they are not the same, you have to be able to provide exact answer why these results differ. Because sometimes then they can, right? And here's one good technique called bronze, silver, gold layers. I like it a lot. Databricks is promoting this these days. This is how you can think about the ways of keeping the data. Bronze layer are my raw data. They can have duplicates. They might be of not the greatest quality, but they should have a schema. Silver layer, they shouldn't have duplicates. They should be good for querying. However, they are not yet shared with business users. And gold layer, my aggregates, my cleaned data, the data that is already processed or pre-processed. This is something that I would like to share. So applications can start with bronze data. Business users can only work with gold data. So this is my single source of truth. And something that I see often, I already mentioned it, is real-time everything. I want to have a big data system because I want to process all my records in no time in a real-time fashion. And this is actually difficult. you shouldn't start the development of your system with real-time if you don't have a good business use case, because it's way more difficult than batch processing. So you have to think about late events, early events. And if you think about this, real-time data, one day, they will be dropped because the disks are not done from rubber. So you will have to keep them somewhere, right? So you might end up losing them. So this is also very important. And here a good question. What's the minimum number of days that you should keep your data while real-time processing in a queue like Kafka? Minimum retention. 3 days. Do you know why 3 days? Yeah, what happens if it fails on Friday evening, right? I would like to have those data until Monday. Highly recommend it. Been there, done that. Worth the effort. You've got PagerDuty or different applications, you know. You can rescue the world. And here, one academic thought, Lambda is a good old friend. Even though the left part of this diagram, like cup architecture, people will tell you, some evangelists of the software, that these days you can process everything in a real time. But actually, it's not the truth. Batch layer and real-time layer are different. They serve different needs, they have different purpose, and they are optimized for different things. Kafka is optimized for low latency, but it's very bad when it goes to throughput. Batch processing, like Spark, it has a nasty latency, but it has a huge throughput. And one important thing, when your system lives on and on, you will probably have to reprocess the data. There was a bug in your algorithm, you have to reprocess all of your data. You should support such a feature. So good luck doing this without having a batch layer. Probably your data won't fit into Kafka. And the last point, cloud is the ultimate solution. It's a silver bullet. No, it is not. So if you can afford buying software like Composer, which is Airflow, BigQuery, Dataproc cluster, it's great because you don't have to maintain it. However, it's expensive, and there's an impedance mismatch. Cloud Composer from Google and Apache Airflow are 90% the same, but there are very few details when they differ, and it can hurt you. It probably migration from one to another does not take a day. And actually, for business people, migrating the project to the cloud does not reduce the costs. It doubles the costs. Because during the migration time, between you cut off the old system, you'll pay for 2 systems. So think about it. And is the cloud-to-cloud migration possible? Obviously. However, if I build my system on top of BigQuery, Dataproc, Cloud Composer, and I want to switch to AWS, there's no such technologies. Those technologies were bought. Those are not open source technologies running in some Kubernetes cluster. I bought them because they are reliable, I don't have to support them, I don't have to maintain them. But if I move from one place to another, I don't have them anymore. So it's always a trade-off. And few key takeaways. So that's something that you should think of, and I would say take away from this presentation, if anyone thinks. So start with batch processing if you do the project, then do the real-time. Real-time is difficult, it's way more difficult than batch, and your system wouldn't suffice without having good batch layer. Then never replace the system having one-to-one resolution. Your system wouldn't match all the same functionalities. Most of them can be hold, but some will be different, and you have to be aware of it. Cloud migration is super cool. However, it's expensive. It will double the costs. And it's not like that you will be able to move to any other cloud provider in no time. And then treat business users who have their experience, who are funding the project as a first-class citizen. Even though they don't know SQL, give them UI. UI is selling your data. And as you will share the data with the world, it will pay off. And then give people single source of truth. It's called gold layer. It's about virtualization of the data sets, but give them something that they can rely on, that it's tested, battle tested, that it doesn't have duplicates. Give them the data of the good quality, but even if it doesn't match their expectations, try to understand why the difference come from. Where do they come from? Why did it happen, right? Especially in real time. If your real-time precision is 99%, obviously there will be some differences, right? If you recalculate your data after 2 weeks, there will be late events. So the results will be different, right? Even from second to second. And last but not least, it should be a synergy of the team. You should always, as a tech leader, I'm always repeating it, I'm trusting the business people, I'm sharing my knowledge with them, so all I expect is a trust for my team and my engineers. So if we are given a trust, we can deliver much more. Because there's a nice word that I heard in this conference. If a team cannot pick up their own technologies, this technology team is dead already. So you should have at least some space to experiment, to play around, and to enjoy your work. So this is all from my side. I hope you liked it. If you answered any of the questions or you would like to ask me some questions, you're more than welcome. I have nice suites here and other things, so please join me here or go to the booth of Datumo. We are also in the first floor. So thank you very much.